Good evening, everyone. My name is Tarun, and as a part of CA assignment in second semester of second year, today's my topic regarding electronic circuit analysis is hybrid pi common emitter transistor model. So let us discuss briefly about the hybrid pi model. So my topic name is hybrid pi common emitter transistor model. Introduction to the hybrid pi model. The hybrid pi model is a small signal equivalent circuit used to analyze bipolar junction transistors. So it is a small signal equivalent circuit to analyze the BJTs. It provides a simplified way to understand the transistor behavior in AC signals, and this hybrid pi model is especially used in high frequency circuit analysis and design. This is not suitable for the low frequency circuit analysis. The limitations of the high frequency circuit analysis is the product of hybrid pi model. Here the shape determines the name pi. The capacitor and the resistor are connected like a symbol in a pi model, so it is called as hybrid pi model. This is the diagram of the hybrid pi model. Now the purpose of the hybrid pi model is this model helps in calculating the gain input and output impedance of the BJT amplifier. It allows the engineers to predict how the transistor will behave under small signal conditions. So it is specially made for the small signal conditions, and it also helps us to determine its behavior in small signal conditions. And the hybrid pi model is very essential for designing and analyzing RF and high frequency circuits. We know the radio frequencies are very high frequencies, and it is essential for the analyzing high frequency circuits. Key purposes are high frequency analysis and small signal representation and versatility. The hybrid pi model is versatile. It is also highly accurate for the low frequency analysis by omitting the capacitances. If you omit the capacitances which are connected in a pi shape, then it acts as a small low frequency analysis. It gives accurate values for the low frequency analysis, but while connecting the capacitors in pi shape, it acts as the versatile for the high frequency analysis. So we move on to the next slide. Basic components of the hybrid pi model. The main elements include the transconductance GM and the input resistance RPi. This model also incorporates the output resistance RO representing the early effect. So the early effect is determined by the output resistance RO. These components collectively simulate the transistor small signal response accurately. These components all together combine to give the small signal response accurately. Here the transconductance GM plays very vital role in the analysis of the high frequency circuits. So let us talk about the transconductance GM. Transconductance GM is the ratio of the change in collector current, which is represented as IC, the change in base emitter voltage VT, where the IC is the collector current and VT is the thermal voltage. We know that the thermal voltage is equal to the 25 millivolts at the room temperature. GM indicates how effectively the transistor can amplify a small input voltage. So it indicates how effectively the transistor can amplify a small input voltage. So the input is a small voltage, and the transconductance GM determines how effectively it can amplify the signal. Here we move on to the next slide. Input resistance RPi. The input resistance RPi models the base emitter junctions impedance in the small signal model. So in the base emitter junctions, the small signal model, in the base emitter junction of the small signal model, the input resistance RPi is determined. It is calculated as RPi is equals to beta by GM. Even though the GM is transconductance and beta is the current gain of the resistor. RPi determines how much of the input signal is dropped across the base emitter junction. So the input resistance, the word itself says the resistance means opposition to the flow of current. So the RPi determines how much of the input signal is dropped across the base emitter junction. Here the output resistance RO. Let us move on to the next parameter, output resistance. Output resistance RO accounts for the early effect, which causes the collector current to vary with the collector emitter voltage. We know that the output resistance is typically large, often in the range of kilo ohms, and provide a more accurate model of the real transistor behavior. Including RO in the model improves the accuracy of the high frequency and the high voltage analysis. Here's the diagram of the output resistance. Here the output RO is parallel to the RD, and GM and VT is equals to IT into R0 parallel RT. Rout is equals to output voltage by input voltage, where the output voltage is denoted by VT and the input current is denoted by IT. So we move on to the next slide. hybrid pi small equivalent circuit. So this is the small equivalent circuit of the hybrid pi model, and we discuss about its features. The circuit features R-pi between the base and the emitter with a dependent current source GM. So between the base and emitter we have a dependent current source called GM. V-pi representing the transconductance. The output is connected to the parallel with the resistor RO in parallel to the model output impedance. So here the output is connected to the parallel with the resistor RO in parallel to model output impedance. So what are the applications of the hybrid pi model? This model is used to analyze the small signal parameters such as voltage gain, input impedance and output impedance, and also the current gain. So these four parameters can be analyzed by using the hybrid pi model for the common source, common drain, etc. It is particularly useful when designing the RF amplifiers. You know that the RF amplifiers, radio frequency amplifiers, which radio frequency comes under the high frequency analysis and high frequency transistor circuits. Engineers use this model to optimize the circuit performance and stability. So the main agenda of this hybrid pi model is to stabilize and to design the circuits for high RF amplifiers and the high frequency circuits. Limitations of the hybrid pi model. This model assumes small signal operation and thus cannot predict the large signal or switch behavior. This can be useful for only small signal operation and cannot predict the large signal or switching behavior. And we know that the capacitance which are connected in the pi shape are known as parasitic capacitance that become significant at very high frequencies, but it neglects the hybrid. So the hybrid pi model neglects the parasitic capacitance which becomes significant at very high frequencies. Despite limitations, it remains a fundamental tool in transistor circuit analysis. Although there are few limitations, hybrid pi model is very oftenly used in electronic circuit analysis. And we also, the Miller effect is also ignored. The operating point dependence neglects the parasitic capacitance, low frequency focus. So regarding my topic, I have gathered all the information regarding in this PPT in the references mentioned here. Microelectronic circuits, Oxford University, and the Razavi P, the author in the RF microelectronics. So this is my topic regarding my as a part of the assignment in electronic circuit analysis. I hope you understand. Thank you.